A pleasant afternoon to you, ma'am. This is Group 4, and today we're going to tackle about the project titled More FSM Sequence Detector. But before that, let me first give you a brief introduction of what it is all about. The 1011 More FSM sequence contains 5 total states: the 0, 1, 10, 101, and 1011. The output of the More FSM only gives high when a 1011 sequence is discovered by the More FSM, which continuously monitors a binary sequence from a digital input. The VHDL code of this project has 3 inputs: the clock, reset, and the sequence in, which all depends on the current sequence. And if the sequence is not 1011, the sequence in will always be low. So now let's proceed with the state diagram.
So first, I will explain the reset button. So the interfunction of the reset button is that it can reset the entire process if the reset value becomes equal to 1. For example, the current state is in the final state, which is the 1011. So if the reset becomes 1, it will go back to the initial state, which is the 0. So I will now explain the function of the 0, which is the initial state of our process. So the initial state, which is called the state 0, is the starting point of the process. So the entire process of the sequence depends on the initial state, because as long as it did not proceed to the next state, it will just go back to itself, which is the 0. So its condition is pretty simple. It will go to the next state if the input of the process is equal to 1. So that's the process of the state. So the next state is the point, which will be explained by Miss Farhan.
With that said, after the initial state, in connection to the output EP waves, in 20 nanoseconds, we are now in the state of 1. Therefore, if the next input value would be 0, we could proceed to the next state, which is 1, 0. Otherwise, if the next input value would be 1, we will look back to our current state, which is 1. And on the other hand, in 30 nanoseconds, wherein the state is 1, 0, if the next output is 1, we can further proceed to the next state, which in this case is 1, 0, 1. On the other hand, if the input is 0, we will look back to its initial state. Next will be discussed by Jerome.
For the next state, which is the 101, if the next input is 1, it will proceed to the next state, which is 1011. And otherwise, if the input is 0, it will look back to 10, and therefore continuing the loop. So if the input is 1, it will proceed to the next state, 101, which has an output of detector out of 1. So if the next state, or the 1011, has received a value of 1, it will proceed to the next state, which is 1. Otherwise, if the input value is 0, it will return back to 10 state. For the modification of the FCM Moore sequence detector, we change the sequence from 1001 to 1011, which is this. So we modify it by changing the logic within the begin statement. We also change the variables related to the outputs of each state. So here in this case, within the begin statement, we use a case statement to apply the combinational logic. So here, if the current state is equals to, or the input sequence is equals to 1, the next state would be 1. Otherwise, it will return to itself, which is the 0. If the next state, which is 1, If the input is 0, it will proceed to the next state, which is 1, 0. Otherwise, it will return to itself. Here, we can observe the loopback. Okay. So, for the next state, which is 1, 0, if the sequence in is 1, then it will proceed to the next state, which is 1, 0, 1. Otherwise, if the input is 0, it will return back to the initial state. So lastly, if the from 1, 0, it will proceed to 1, 0, 1. From 1, 0, 1, it will proceed to 1, 0, 1, 1, which is the last state, and the sequence is detected. Here, if the input from 1, 0, 1 is 1, it will proceed to last state. Otherwise, it will return to the previous state. And the last state, which is 1, 0, 1, 1, if the next signal input bit is 1, it will proceed to the 1 state. Otherwise, it will return to the 1, 0, where we found the bit 1, 0. So,
to further understand about the functionality of the reset, we will try to modify the reset's value to be equal to 1. So, we will try to run. So as we can see that from the output of the EP wave, the current state on the initial state, which is the 0, because it was not able to proceed to the next state, because our condition states that it can only move to the next state if the value of the reset is 0. So we will now try to change the value to 0 to see what will happen to the EP wave. As we can see from the output, since we changed the reset's value to be equal to 0, it now proceed to the next states from different states, which is from 0 to 1, 0, 1, 1, which is the final state of our code. So that's all.
I learned that FCMs or finite state machines are helpful when it comes to modeling real-world life scenario. So, for example, an example of a real-world application is the elevator, wherein if the user or the passengers request to the elevator to go to the top, it will first close the door and have a time out or delay when it comes to entering a passenger. So if the elevator room is at the top, it will return to itself. Otherwise, if the passengers wants to go the other side or the down floor, it will return back to close the door first, and the loop continues. That's all.
So, for my reflection, After completing this project, I was able to learn many things, especially about HDL codes. This helps us improve our skills in terms of debugging, modifying, and lastly, implementing the different learnings from our previous activities. So, overall, I think this is a good experience because we're able to apply our own knowledge and techniques to be able to come up and complete our HDL project. So that's it.
With all that said, in this project, we were able to manifest the skills and knowledge that we have successfully acquired throughout the duration of this course. The modeling of the VHDL codes together with the output EP waves and truth tables is an explicit manifestation of our competence in designing experiments, analyzing, and synthesizing information as per required by our professor. Thank you for listening.